Okay, hey guys, welcome to the ACM Hack X Girls Who Code workshop on C++. So this is going to be like an introductory level workshop on C++. If you've used C++ before and want like a quick refresher, or if you've never used it before, we'll be basically just going over all the basics and fundamental syntax of C++. And so I'll be presenting this with Han today. Han, if you want to introduce yourself.
Sure, yeah. Hi, so I'm Han. I'm an event intern from Girls Who Code. I'm a technical event intern, and I'll be presenting with David about C++ in this workshop, I guess. Dipansha is not here because she has discussion, but yeah.
Cool. Okay, and if you guys want to check in, the check-in code is ACM Hack and Girls Who Code, or yeah, Girls Who Code, exclamation point. Cool. And if you guys come in late, or if you miss it, it's just in the bottom left. Cool. All right, so today we're going to be going over a bunch of different things. We'll start off with the basics like hello world, and then we'll go through input output, data types, conditional statements, loops, functions, pointers, arrays, and then lastly vectors. So a bunch of cool features in C++ and stuff that you see in like a lot of other coding languages, but C++ a little fancy or like weird, I guess, of their syntax. So we'll be going into all the nuances of how C++ does all that. And yeah, just to start off, I'll pass it off to Han to talk about hello world in C++ and like the basic syntax of a empty C++ file.
Sounds great. So the first three lines of the code, if you have programmed before, this is pretty standard. It's just importing library. In here, import in C++, import is hashtag include, and then the name of the library, and then you have to put it into the the sign, the less than and the greater than sign. Using namespace std. So this is a pretty, I think this is a C++ thing. When you want to like print out something, you have to call in the standard library and then dot colon cout to print. So when you include this line using namespace std, you don't have to do the whole std colon cout every single time. You can just do cout. The main function, this is the first function that you will call in your program. Again, if you have programmed before, this is just to initialize the program when you compile and run it. So yeah, we start with the main function. Printf is how you print in C++. And in here, we're just printing hello world. And return 0 just means that the line of code is executed successfully. So David, you want to take a little more on that?
Yeah, sure. So let me just copy this code over into Replit. And so if you guys haven't used Replit before, it's a cool like online IDE. If you want to go to like riplit.com, and you guys can like quickly create your own REPL file basically. And it lets you like run code in a bunch of different programming languages. So in this case, I just made like a quick one with C++. And so it gives this like little C++ environment where you can type in code and then a console as well. And so I'll quickly just copy over what we did before here. And if I press run, you can see it'll print out hello world. And in the example before, they had cout. So cout is another way you can basically print to your console. Printf is just like another method you can use to print. I think more commonly cout is used. And as Han was saying before, like std, usually like when you use a method from the standard library, if you want to just like get rid of this like std colon thing, you can just type using namespace std. And basically what it means is like, okay, it knows that we're going to be using methods from the standard library by default. And even though you still have to import like different stuff like IOStream to do a cout statement, you can just drop the std and it'll still run without any problem. So one cool feature about C++. But yeah, if you don't have this namespace std, C++ is going to get angry at you. It's going to be like, yeah, use of undeclared identifier. And yeah, it sometimes pretty smart. Oh, what's up?
Yeah, so it's like the use of what's called the namespace. Is that like a Java inheritance? I mean, as far as Java is the only language I know. So is that like analogy?
I don't know if it's like inheritance. It's like more just saying to C++ like, okay, like we're gonna be using libraries like by default in like the standard library. So std is like abbreviated, I think, for standard library, and like even though we can do these include statements to import stuff from the standard library, basically it just says like, okay, like I don't have to clarify like I'm using like a library outside of the standard library because there's like different ones depending on what you're making in C++. Like if you're doing like game development, there's like special namespaces for game development. But this just indicates like, okay, like by default, I'm going to be using methods from the standard library. Okay, cool. And yeah, so we'll move on to standard input and output. So first, like I showed this a little bit before, we have standard output. And basically, if you want to print something to the screen or to your shell, you'd be using cout. So yeah, the syntax is a little funky compared to like Java, where you just do like system out println. In this case, like you can use printf like we were showing before, or you can use cout. Personally, I think cout's easiest because it allows you to like chain statements together. And it's just like a clean syntax. But essentially what you're doing is you have cout and you're saying, okay, I'm sending like with these two arrows, this like information to the output, so to the console out. So in this case, like it'll just print output sentence to the screen. But you can also just print numbers to the screen. So instead of doing a string, you can do 120, and you can also just do variables as well. But one of the cool things with cout that I really like is that you can chain statements together. So in this case, say you wanted to print out like I am, and then you store like the age of someone in a variable, say years old, and my zip code is zip code. So what this will do is it'll basically allow you to chain variables together. It's like a way of formatting strings really cleanly with your print statements. And it'll all just like append into one string and print to your console. One other thing with cout, with like, I guess like printing to the screen that you should know with cout is the end else statement. So if, for example, like we just do this line like cout or like coutx, what it won't do is create like a new line character, meaning like it won't break to the next line. So let's say like I printed out cout output sentence here, and then I do 120, it'll just print out like output sentence and then like 120 afterwards. So by specifying endl specifically, we're saying like, okay, we want to go to a new line after we make a new print statement. Otherwise, it's just going to continue on that same line. So I'll quickly like demonstrate that through the output. Can I clear this? Okay, cool. But yeah, say like we have hello world, and then we have like the new line character. So that's another way you can do it. You can just do the new line character, and I just print here. This will just be hello world, and then another line for here. But if you get rid of the new line, we just do hello world space. You can see now it's going to be on the same line, and you can see the pointer too for the console is going to be the same line as well. And so like similarly with the new line character, you could just do endl and do endl here just so our console's on the next line as well. Print this out, and you'll see it's on two different lines. And also just to quickly demonstrate like how you can chain stuff together. So let's say like here is the number, maybe this, and let's say like 17. Cool. And yeah, so that's like the essence of like how you would print in C++. Does anyone have any questions about that before we move on?
Yeah, Nick has a question in chat. Can I do output sentence greater than sign to cout? If you want to quickly demo that too.
Yeah, so I'm pretty sure you can't do that. So the left arrows indicate you're like sending it to cout. I think only with like sending inputs, you can do the right arrows, but you know, let's just give it a shot and see what C++ says. Yeah, so I think it's already angry at us. Yeah.
Yeah, I think greater is meant for cin.
Mm-hmm.
And yeah, less than is for cout. Does that answer your question, Nick? Okay, cool.
Cool. And yeah, we'll show the standard input really quick. So if you want to give information to your program, so through the command line, if you want to like type in an input, that's when you do cin. So in this case, we have age. So first we have to declare the variable that we want to store information into. And then afterwards, we can use cin to pipe that information into the age variable. And so we have another example before. Let's say like you want to enter an integer value, and you can see there's no like endl character here, so this will all be on the same line. We'll add a cin line. So we're saying is whatever the user inputs will be piped into the variable I, which we declared here as an integer. So in the case of like we type in a string, for example, it'll give us an issue. It'll throw an error. But if you give an integer, this should be fine. And we can do cout. So as you can see, this using the left arrows instead to send that information to this output. It prints out the value you printed, and then in this case, it'll also print double that's value. So let's give a quick example of that in Replets. Okay, so cool. Let's say like let's declare a string, and let's just call it like input. Yeah, we could just call it input. And so let's just say like, okay, cout, give me a word, any word. Cool. Oh, sorry, bad syntax. Remember, left arrows for cout. And in this case, we run this really quick, and as you'll see, oh, it's all in the same line. And so now if we specify cin, so right arrows indicate we're going to be storing information into a variable. We want to store it into input. And now if we do this now, it'll give us this little box right here. You can see, okay, it's waiting for your input right here. So I'm just going to say word. This is the word we're giving. Press enter. In this case, we don't really do anything else with our program. So it's just going to exit. But now we can do something with input. So just to prove that we stored it in that input variable, we do cout input. And here we go. So let's just say, just gonna do keyword spam, prints that out. There you go. So that's like the main way how you get input from the terminal. Pretty straightforward, I hope. Does anyone have any questions about that before we move on to data structures? Cool. All right, I will pass it off to Han to go over the basic data types in C++.
Okay, so basic data structure. Here are the list of primitive built-in types. So we have the standard, integer, Boolean, characters, char. We have floating point, double, and also have void, character. These are pretty standard data types that you all hopefully have seen before. And here are the keywords of these types in C++. So yeah, pretty straightforward. There's also a lot more. So here's a source for you all if you're interested. But yeah, here, the one on the screen are the most popular ones. Next slide, please.
Sorry, what are you saying, Han?
Oh, can you move on to the next slide?
Yeah.
Yeah, so for data type, you can also modify using the following keywords. So for basically, these just specify the number of bits that the data type would have. So for int, standard is 32. I think for unsigned, it will go more than 32. I think it will go up to 64. We're not entirely sure. But yeah, these keywords will signify the number of bits that you would have. So you can do a sign int. That means that you can put in negative numbers. You do unsigned, you can have both negative and positive. These are will be helpful when you start using, for example, length to return the length of the string. The return type would be an unsigned int. So when you write a for loop, for example, for int I, you would need to use for unsigned int so that the program doesn't complain. So I also include some of the commonly used data types, including the number of bits. And yeah, the percentage and the letter is just signify to, when you use printf to print, you will need to use these notations specifically so that it knows that you are printing an int variable, a long variable, for example. David, if you want to do a quick demo on like print an int, for example, yeah.
Yeah, sure.
And also you can like print multiple like data types together also.
Yeah, so also just like to add something on. So these keywords, like if you take in CC30 or like, I'm not sure if it's not covered till CC 100, but usually like these just allow you to access like a wider range of numbers. So like long gives you like more numbers to use, short basically takes away some bits away. So like you're using less space in your program. Typically like you don't really have to worry too much about these unless you're like very memory concerned. The ones that I think are most common, or I think the one that's most common is probably unsigned. So using unsigned basically like gives you more of a bit range to create larger numbers. So typically it's good syntax if you're not going to be using like negative numbers or something. But let's say you have like a for loop that goes from like 0 to 100, and you know you're not going to be using any numbers that like variable I, then you can just clarify it as unsigned. Just good syntax to, or good practice, I guess, in general, just to use unsigned when you know you're not going to be negative. Also, like say for example, you store like a negative number in an unsigned variable, it'll basically wrap around and like create like a really large like positive number. Because how it works in like, I guess binary is like the 1 in the leftmost bit will like indicate that a number is negative. And so there's all this like 2's complement magic that goes on when you use when you try to store a negative number in an unsigned variable, and you'll get unexpected results. So if you take like computer security classes, that's how like buffer overflow happens as well. But don't need to worry too much about that. These are just good to know, and good practice just to know when you're using like signed and unsigned variables. And so I'll quickly give a demonstration of some of like the basic data types in C++. If you've done Java before, it's all very similar. But yeah, let's give a quick demonstration. Okay, so in this case, like if you're going to store a number, let's just say, thanks, Nick. Let's just say we're going to store a number. You can store 5 in a variable int. You could also do like double. So let's say like number 2. You could also store 5, but if you're doing a double, you can also do like 5.0. Like you have that decimal place range to also work with. Same thing with float. I think float just gives you an even wider range of numbers to work with. So you can do like 5 point whatever.
So it'll
And so
give
you
you
can
like
make,
64 bits, I think.
yeah, 64 bits. I think, do doubles only give you 32 bits? Is that the deal? No, they also give you 6. Oh,
Oh,
so
right.
doubles give you more space. Floats give you less, I suppose. Yeah.
Okay.
But yeah, doubles and floats pretty similar, I guess, just the bit range. They both allow you to use decimal point numbers. One of them just gives you greater access to more numbers, I suppose. And let's demonstrate Boolean. So if you guys have taken like Java, you know that like Boolean values can store true or false values. So you see a true in here. So in this case, in C++, it's going to be lowercase true. I think in Java might be uppercase with a T, or maybe that's Python I'm thinking of. But true or false in Boolean values, anything else will be an issue. And what else? Void. So I think void pretty similar. Like if you're going to call a function, let's just make a void function, and we'll just call this like f1. Takes no input, and this one will just like print out like this is a void function. And you can see like this isn't going to throw any issues because we're not actually returning anything. If, for example, we had like int f2 and we're like, this is a non-void function, and we don't return anything, you can see there's a highlight here and it says control flow reaches end of non-void function. Basically it's just saying like we didn't return anything, so this isn't going to compile correctly and you need to fix this problem. But when it's void, you don't need to worry about return types. Just a good thing to know for when you're writing functions that you don't need to return any information from. And yeah, also chars. So chars are not the same as strings. You can have char pointers in C++, but I think that's a bit out of the scope of this like intro level stuff. When you have a char, I guess like it's basically just a character. So in this case, like A is a char. And one thing you also have to be careful of is wrapping it in single quotes. If you do double quotes, C++ is going to think it's a string. So it's going to say you can't initialize a variable of type char with the L value of whatever. So you don't need to worry about that too much. All you got to know is that when you're doing a char, it has to be in single quotes. And this could be anything like the ASCII value range. So as long as this is a valid char character, then you should be fine. I think also you could store numbers in chars. So let's say we do 73. This will basically evaluate to like whatever the numbers or the character 73 would be in ASCII. So let's actually give this a shot. I'm wondering what this is. So it's I, capital I would be 73. And so this is useful if you're taking like CSC 12. I know you have to like, or at least you used to have to know this to store values and numbers. It makes your life easier, especially if you're like working with ASCII values a lot, but just a good trick to know that you can store numbers and chars as well. And yeah, I can also give an example of like unsigned. So you can have like an unsigned int. In this case, like let's say we try to store -5, and let's print out what -5 would be in the terminal. Run this. You can see this is like an absurdly large number because the binary representation of this number is very different when you add that negative sign. And so C++ is going to think this is a very large positive number when in reality it's just a very small negative number. And this is all because of the 2's complement magic. So yeah, I think that covers most of the basic data types. Do you guys have any questions about that before we move on? I think this is another slide as well, just showing like some of the stuff we were talking about before. So you can use like string formatting with printf. That's one thing you can't do with cout is like easy string formatting. So printf especially comes in handy when you want to like insert stuff into strings in specific locations and you don't really feel like using that cout syntax. So if you're familiar with like dot format in Python, it's basically the same thing as this. You just need to specify, I guess like %C would be like a character, %LF stands for like long float, or double in this case. Long floats and double is like the same thing. And yeah. Any last second questions?
Not a question. Oh,
Can you
Marcelo
do
have a
colon
question?
D for double? I think you can, but I'll give that a shot right now. Colon D. Oh, maybe not. I know in Python you can, but I guess for C++ they don't allow that. Yeah. But basically like a long float, I'm pretty sure. Wait, what? Long float's invalid? Oh, maybe not. Why did it say ints? I'm not sure where you saw that.
I think because %D is an int type, or like the formatter for int. That's why I said int.
Oh, right.
Yeah,
Yeah, I think,
that's how you
was that in the
print
slide?
int in C++. Yeah.
Right, okay. Interesting. Okay, maybe I don't know what they stand for, but I guess, yeah, so D is used for, I guess, integers in this case. I don't know. I think it's definitely worth looking into. It's probably something like old with like the C++ syntax when they were first making the language, but if you guys want to look on that in their free time, probably like some pretty interesting reasons why these are all named this way. For me, whenever I have to format strings, I usually just refer back to probably something like this tutorial point, just because I always forget what they are. But thankfully you can just like search it up. Now, let's see. Yeah. Okay, we won't focus too much on this, but I'm sure there's like interesting reasons why they use this naming nomenclature.
Yeah. One more thing to add on the basic data types. You might be wondering why there's no string in here, because string is pretty, I guess, is pretty basic. But string in C++ is actually a class of characters, so chars. So string itself is not a data type, it's a class. So you can declare a string normally, like how you define, like what we have been defining, like characters and all. But yeah, string here is not a data type, it's a class. And that's just a C++ thing.
Yeah, and as you can see, like strings are part of the standard library. So
Yeah.
when you import into SUD, it lets you do strings, but like if you don't have this, it'll cause issues. So yeah, but stuff like an integer, for example, I think it's just like built into like, yeah, it's built into C++. So if you need strings, remember to specify a namespace STD.
Yeah, so use namespace std to use string. Okay. I think we're good with data types.
Cool. Okay, yeah. So conditional statements. In this case, C++ supports like pretty much the standard conditional statements you'll see in Java and like other common programming languages. So want to do less than, A is less than B, just use the less than symbol. I'm not going to go into all these, but like it's all pretty straightforward. If you've used another programming language before, it's going to be the exact same for those conditional statements. So logical conditions are pretty much the same. Also, like I think one thing is like doing the double and. So like similar to like Java, if you wanted to do like, let's say like C out true and false. Does this work? Oh, I need to import namespace std. And let's try this. Yeah, so just use ands to indicate like you're doing a comparison. Same thing with like oring. So this will print true. And same thing. Yeah, if you want to do like binary comparisons, you can do single bracket or like this, but we're not going to go into binary in this workshop. Yeah, this XOR as well. So you can do like the XOR symbol. Is it not working? Well, I know XOR is in C++ somewhere, but anyway, that's how you do like logical conditions when you're comparing two logical operators. But
so just to point out, you can compare like characters also. Like it doesn't have to be numbers. So it's not like math where you have to compare like two numbers. You can also compare like letter A with letter B, because then the computer would just turn that into ASCII value and compare that.
Okay. Yeah, sorry, I'm not sure what I'm doing. Just trying to figure out what's going on there. Okay, cool. Oh yeah, I love that logic gate. Me too. Me too, Marcelo. Okay, cool.
Cool. If condition, again, pretty straightforward. If you give it some kind of condition, so if the variable x equals 0, I want to return true. So if open parentheses, some kind of condition, bracket, curly bracket, and then you put in whatever the block of code that you want to be executed. If the condition is met, then yeah, and then I think we have else also, else if you want to include like multiple conditions. Other than that, it's pretty standard compared to like other programming languages.
Yeah, so just to demonstrate, let's say we have a variable string ACM hack that will store is the best. And so we'll say like if ACM hack is the best, then we can just print facts. I guess C++ has spoken. We're the best. But yeah. Oh yeah, one thing too, I don't know if a lot of people know this, but like when you have single line if statements or for loops, you can just like do it in the same line. I always thought this is a cool trick because people didn't know about this. You don't have to do the squiggly brackets if you don't want to, but yeah, just for clean syntax. Yeah. And then for loops as well. So same thing with like, using Java or other similar programming languages. You have 3 statements. So statement 1, I think it's good to know actually. Like I didn't actually know this until I looked more into it, but like the first statement, something that's only executed once. So like that's where you do like the int I equals 0. You declare that at the beginning of your code block. The second statement is like what's actually executed before you run this code block. So every time it loops over, it'll check, is this statement to true or false? If it's true, we'll go into the block. Otherwise, if it's false, we'll go out. And the statement 3 is executed after the block has already started. So let's say we reach the end of the block, then statement 3 is going to be executed. And that's how you do like I++. Yeah, so yeah, I guess I can just quickly demonstrate it. So for, let's just say int I equals 0, I is greater than 5, and then I++. I don't know if you guys are ++I people or I++ people, but I think everyone knows that I++ is better. So this will print facts 5 times. Post increment gang, yes. Doesn't make a difference you do this, but If you do I++, I like you a little bit more. Okay. Cool. Any questions about if statements or for loops at this point? I hope I'm not going too fast. I'm kind of just making the assumption that some of you guys, or most of you guys, have already seen these statements before. But if any of you guys have any questions, like feel free to send me a private message or on a private message, and we can help you out with that. Cool. And we'll move on to functions.
Yep. Function, David already did like some of that earlier. But yeah, we can have a void function. Void function, again, you don't have to return anything with void, so you can print something like cout, I just not execute it. For a function that requires you to return something, you should start with the return type. So it can be an int, a string, or a character, and then name of the function. And then at the end, you would need to have a return statement, like return 0 during in main here. And if you recall David doing a little bit of that when he did F1 and F2 functions, that's how you declare a function in C++.
Yeah, so function syntax is pretty similar to C in C++, very clean. So you just declare the type that you're returning, the name of the function, you pass in any parameters you want, and then these squiggly brackets, and inside you'll have the function execution. And what did I write in the right here? Yeah, so we just have to specify the data type we're returning. But yeah, I don't think there's like much polymorphism in C. Someone can correct me if I'm wrong. But actually, I'm sure there is, but typically the syntax is very clean in C++. If you're implementing like certain class types, I guess, like methods of a certain class, there's interesting syntax for that. I think object-oriented stuff in C++ is a bit outside of the scope of beginner stuff for this workshop, but that's also some interesting things you can look into if you'd like. Cool. All right.
Okay.
Yeah, go ahead on.
Yeah, I'll cover array. Array is just a collection of data of the same type. So for array, when you declare an array, you have to give it a data type. So it can only store, let's say, want an int array, then you can only store integer in it. So you cannot have an array that store an integer and a string. It's a collection of, again, same type of data stored in contiguous memory. When you declare an array, you have to give it a size because array is undynamic. So you cannot allocate memory as you go. You have to allocate memory when you declare or initialize the array. And then array can be multi-dimensional. So I just have pictures of a 1D array. So standard array full of type int. Again, similar to most programming languages, you start with index 0. And an advantage of an array, so when you probably would think about when do I want to use an array? You want to use an array when you need to quickly retrieve something from the data, from the array, because it would take linear time to do that. If you use like vector, for example, you have to like go through or loop through each node in the vector and then to get the data. But then with array, again, you can just access the data with syntaxing, with indexing. And yeah, multi-dimensional array, instead of doing ARR size, you can just do ARR X, Y. Yeah.
Yeah, I'll quickly demonstrate like a bunch of cool ways you can declare arrays in C++. So
yeah, I have a sample code too if you want, but if not, it's fine.
I just realized I muted accidentally. Yeah, I'll show us a few ways that you can create arrays in C++. So the most standard way is like, let's say you have like an integer, or let's just say like integer foo, and we'll declare this as an array, and let's say you want like 5 spots in this. I think you can just do this. So this is like if you have nothing in it and you want to do just an array with 5 elements you can store, this is the most simple way you can do it. One thing too is like you can already fill elements inside of the array. So let's just say like 1, 2, 3, 4, 5. You can just use these squiggly brackets to directly store elements. And then if we add 6, I think it'll probably get mad and it'll say, yeah, too many elements in here. Another thing you can do if you don't really want to specify a size, but you want to like insert the elements already, just get rid of that number, and C++ will automatically know, okay, this is going to be an array of size 6 by default. And yeah, two, like if you want to just do this, and you can also specify the size, you can just have an empty array 7, and then like you just have the first element as like 0, for example. Another way you can do it. And yeah, I think that's pretty much the basics of that. Let's say like we want to update an element in the array. So let's say we want to update slot 5 and we want to store the number 2 in it. All you got to do is just specify the index of that. So index 5 and store 2 in it. Unlike MATLAB, arrays thankfully start at 0. So if we do index 7, this will be an out of bounds issue because even though our array is of size 7, our indices only go from 0 to 6. So yeah, starting at 0 is the way to go. Okay. Yeah, there's also like cool ways you can do like memory management. So like, I think if you do like, let's say we have like 1, 2, 3, 4, 5. All right, the MATLAB slander is justified. I apologize. Let's say we have like array at, let's say like array at 5, and then we want to do 2 elements ahead of like foo at like 2. We can just do foo of 2 plus 2. Wait, is this right? Hold on. No, this will be foo of 2 plus 2. I think we do like the address. Wait, I think a pointer is too much. No, this will just add to the element. I'm being stupid. But there's different ways to do like memory management with arrays in C++. Because it's all stored in contiguous memory, you can quickly access like the number right next to it just because it's like literally right next to it in memory physically. But yeah, we'll talk a little bit about pointers too in just a minute, which are another way of doing this kind of stuff. But yeah, I think up next is
I got a
more about arrays.
I got a private message for question.
What was the question?
Someone asked, what does the equal sign do when coding for an array?
So do you mean like this, like equal here, or?
I assume so. If you want to clarify me in private chat, but if you are referring to the equal sign here, we're just like setting that. Yeah, so they are referring to the equal sign.
Okay, yeah. So in this case, like what we're doing is we're just like setting this array equal to this set of numbers right here. So this array with 7 elements is going to store from 0 to, I guess, index 4. So in index 0 it's going to be 1, index 1 is going to be 2, etc., all the way up to 5. And so I don't know if you can actually print out. Yeah, you can't print out arrays cleanly in C++, unfortunately, but this basically just like sets the array equal to a set of numbers that we're pre-filling. And so in this case, like let's say we want to update the array index 0. So this first number is going to be 1 originally. We can use the equal sign to override that 1, and in this case, like store 2 inside of it. And so now if we go through each element in the array, so I'm going to do something a bit illegal in a sec, but a for each loop. So for each num in foo, print out num. You see now it's going to be the numbers 2, 2, 3, 4, 5, and then as you see, we allocated size 7. So there's 2 zeros at the end, because when you declare an array, an int array specifically, it'll just fill with zeros. So say we do this, you see it's all going to be filled with zeros by default. Oh, okay. Well, it usually would be filled with zeros by default if there wasn't already memory in those positions. So in this case, because we didn't override these numbers right here, this is like old memory that's bugging out. So yeah, C++ memory management is very efficient, but also very confusing sometimes. So I think maybe if we do this, it'll work, question mark. Yeah, this will fill it with zeros.
Yeah, so I have a picture of the array that David initially declared, but this is how it looks. So when you update, so line 7, basically you go into that specific spot, you replace that with the new value. I hope that's clear enough. Any other
Cool.
questions? I think we're good.
All right, now to the fun and very confusing part of C++. So here are pointers. In essence, pointers are a variable that store a memory address to its value. So when you store something like a string, for example, and you store like pizza inside of it, basically we're storing this like at some point in memory. So like as like Han was showing before, like we have memory blocks that are laid out, and like in this case, it's gonna be like P, I, Z, Z, A in memory. And in this case, this is all stored like at one specific location. So let's just say this is stored like 0x like dead beef. Gotta love dead beef. And basically what we're doing, if we like store the reference into a pointer, we're basically storing the address of this string to be declared food, in this case, dead beef, into a variable. So in this case, a string pointer is literally just going to be the address dead beef. So in this case, like when you store a reference into a variable and we have a pointer, it allows us to like directly edit that memory specifically. So like if we, oh man, this is hard to explain. By using pointers, we're allowed to like pass around memory without having to like reallocate stuff. So in Java, it kind of does it automatically for you. Like when you pass in an object into a new function, that object's going to be the exact same as the one in that original function. But in C++, we have to like be a bit creative with it, because when you usually pass in something into a function, it'll just make a copy of it. So the reason why we use pointers and references in this case is because we want to make sure we know exactly like what memory we're changing, rather than like a copy of that memory. So it's really difficult to wrap your head around at first. And I know I just gave kind of a botched explanation, but I'll try my best to show it in just a minute and how we can use pointers effectively. So in this case, like when these cout statements, you can see this will just print out pizza. In this case, if we're storing out the reference to food, in this case, memory address, it'll just print out this memory address right here. And then if we want to print out the pointer as well, the pointer is going to be equal to the memory address. And so in this case, it's going to print out the same thing. Cool. And so let's give a quick demonstration of how you can use pointers. Actually, I'll first kind of explain why pointers are used. I already kind of said this before, but pointers allow you to directly modify memory created in another function without making a copy. So let's say like we have string, let's say we have like integer num, and we'll call this like 5. And let's print out like what the memory address of 5 is. So in this case, num is stored in memory at this address 7ffde whatever. And let's say like we pass in num to like another function, we'll call it f1, and we pass in this num, and we'll print out like what this memory address is here. So let's call num, or let's call f1, pass in num. And so we'll have our first memory address here, and then the next line will be this other memory address. As you can see, this has DC at the end, and then this has BC at the end. So this is actually at a different location in memory, although they're like close together. It's not the exact same location because C++ made an exact copy of it. So let's say we want to pass in like the exact memory address of num. So we want to edit like num in memory. Or actually, a better way to show it is just like editing num. If we try to edit num right here, so let's say we put the number 6 in num, and we don't do anything else. Now, what do you guys think is going to happen if I try to print out what num is? Does anyone have any guesses? I'm going once, going twice. All right, let's see what happens. All right, prints out 5. The reason why it prints out 5 is because C++ made a copy, and so let's pass it in by reference instead. So in this case, we're passing in a reference to num, And now we don't have to actually change any of the syntax, but by specifying we're passing in a reference, and we change num to 6. If we print out num one more time, you can see now it prints out 6. So typically it's good syntax to use references when you want to modify like a number, or I guess like anything in memory that was used in another function. You could also do pointers. So in this case, like you could do this and you pass in directly the address of num to the function. The main difference we have to do though is when we're declaring a pointer, or like, I guess we're updating a number stored in a pointer, we have to do something called dereferencing. Can it lead to a lot of easy anti-patterns? What do you mean by like anti-patterns, Nick? But yeah, in this case, like if you pass in a number by reference, or sorry, by pointer, we'd have to dereference it here. And basically we're saying is like, okay, we're gonna find whatever was at that memory address, and now we're gonna update it with the number 6. So another way of doing the same thing, I would say usually the common notation is to pass in by reference, so by using this, and it kind of like abstracts away some of the pointer magic. But it's really a matter of preference in whatever way you want to do it in the end. Yeah, so it's okay if you don't understand this right now, because pointers are really confusing. And for me, when I took like CSE 12, it took me, a couple of weeks to really understand what was going on under the hood, because memory management is not like a super easy thing to understand. But if it's your first time seeing pointers, like feel free to like look up some tutorials online. Once you do understand how it all works, it's actually really cool. And like I personally like really like C++ because of pointers. It like gives me a better idea of what's actually going on under the hood, and you have a better understanding of how memory works. Meanwhile, in like stuff like Java and Python, it's all abstracted away from you. But in C++, you have like a much better understanding of like where everything is actually lying in memory. Yeah. Cool. Does anyone have any? Oh,
so
sorry.
yeah, you get to learn about this a lot more in CSE 30. Like I think half of the class is about learning pointers.
Yeah, so if you're a new CS student, there's plenty of time to learn what pointers are, but definitely a good thing to know and understanding like how memory works in programming, because it will come up in a lot of your upper-div classes for sure. Okay, cool. And then like Han's gonna finish up with vectors.
Okay, so vectors are the same as dynamic arrays, but vectors, unlike array, it can dynamically resize itself. So when you declare a vector, you don't have to give it a size. Recall when you declare an array, you have to give it like an actual size, right? So like int foo 5, for example, then you will have 5 spots in the array. With vector, it grows as you add more elements into it. So piece of code here, you declare a vector, for example. Then for when you loop through, pushback is how you add element to a vector. I think you can also do this to add element into vector, but yeah, pushback or the syntax or indexing. Yeah, pretty straightforward. So it's an array, but you can dynamically allocate memory to that array.
Yeah, if you use array lists in like Java, for example, it's the exact same thing as an array list. It's just a dynamically allocated array. And yeah, you can use this syntax, but only if like you've already added a slot into that vector. So the way vectors work is I think like it doubles every time you fill it up. So like let's say you have like one element to start off with in the vector, and like you want to add a new element, like then it adds like another spot. So you have like, I guess, oh, this is bad to demonstrate, but it'll be like this. And then like, okay, say we want to add another element. Okay, now it'll add 4 slots. So you have 1, 2, 3, 4. And like, let's say you like fill all these up for some reason, then it'll go to 8 spots. And so it just like doubles every single time you fill up that vector. So yeah, just one cool feature of like how dynamically allocated arrays work in C++. And yeah, I can like quickly demonstrate this, but very similar to array lists. Good to know, and like easy syntax in my opinion. Yeah, I'll just copy this over to our little code example. Yeah, while I'm doing this, if anyone has any questions, feel free to ask. Okay, why is it? Oh yeah, it's also mad at us because we didn't actually include the vector class. So when you use vectors, remember just like you have to do the library include. So just specify I'm gonna be using vectors in this file, and so just including vectors how you would do that. Cool. And in this case, we add numbers 1 through 5 to our vectors. So pushback is like one of the weird syntaxes with C++. I think push front also works. No? No. Okay. Yeah, but vectors, if you want to add to the end of the vector, all you do is push back. I think, yeah. I guess there's no autocomplete in here. Vectors have a bunch of cool features though. Maybe I could just pull it up in the C++ documentation. But one cool thing you can learn about C++ is iterators, which allow you to do some cool things. Okay, yeah, pop back, so that allows you to delete the last element. You can also insert at certain locations. So if you want to insert at like position like 3, for example, syntax a little weird with iterators. Again, like out of the scope of this workshop, but yeah, vectors are neat to mess around with. And understanding like iterators work is another cool thing. But yeah, I think that's pretty much it. So yeah, thanks guys for coming to the workshop. If anyone has any questions, we'll stick around and feel free to ask anything. I know it was a lot to process at once if you're like new to C++. But yeah, feel free to send us any private messages. And thank you guys again for coming.
Thank you, everyone.
Someone asked me in private message, like, how do you run the code here? So in this case, like we're using Replit. So I'll quickly like show the website, but it's just like replit.com. Thanks, Nick, for coming. And basically once you make an account, there's like a few buttons here. You can just like create a Replit right here. So press this little plus button. You can select a bunch of different languages. So in this case, we're using like C++, but I'll just show like Python, and then you can name it whatever you want, create it here, and you can edit your code and like run it in this little code block. So in this case, I'll do like a quick print statement, hello world. Yeah. But if you want to like set up your own coding environment, I think ACM has like a workshop on the website of or on our like YouTube channel on how to set up your own development environment. I can find that really quick for you guys. But while I'm doing that, someone messages me like C++ seems kind of mechanical. Why is it so widely used in software engineering is because of memory management properties. I would say yes, like C++ has really good memory management properties, and like it's also like been around for so long that there's like a bunch of really available tools available for it. So like library wise, it's very extensible. Yeah, I think C++ and Java are probably the most widely used languages in the software engineering industry. Java might even have more libraries at this point compared to C++, but I would say like the very clean like memory syntax makes C++ better. Oh, also like one other thing I forgot to mention is like memory or garbage collection. So one thing with Java is like it'll automatically allocate and deallocate memory for you. With C++, if you take like CSC 12, you'll learn that like you do all your memory management by hand in C++, which means like you decide like when you add memory or when you delete memory. Java, you can like determine when you add memory, but like when you want to get rid of memory, Java will just do that automatically for you. With C++, you like tell it exactly when you want to get rid of memory, and it basically makes your code faster in the end. Garbage collection in Java slows down your code just a little bit, and it's a trade-off like some companies are willing to make. But if you really care about efficiency, which a lot of companies do, C++ is always better for that.
Also, to add on to that, I think to clear memory in C++, you have to call like a specific function.
Oh yeah, it's like delete.
To deallocate a pointer. Yeah.
Okay, so just to give this video, so if you guys are interested in like setting up a development environment, we have this video we made last month, and so it'll help you like set up VS Code and stuff like that. It's a bit of a long video. If you want like a much faster one, so this is like a 5-minute version. That's probably not as comprehensive. Feel free to check that out. But yeah, it's a good way to help you get started with like setting up an environment for programming. Cool. All right, guys, I'll stop the recording here.